Hello everyone, welcome to another video lesson. In this lesson, we are going to go over notes 2-6, which is proving angles congruent. So let's start with a theorem. A theorem is a statement you can prove. So don't forget, we just finished learning about conditional statements, so it's a statement you can prove. And this is what theorems are, they're conditional statements. So let's start with the first theorem, and this is called the vertical angles theorem, and this one says that vertical angles are congruent. Okay, that's what the theorem says. So if you look at this diagram here, angle 1 and angle 3 are vertical angles because they're opposite to each other at the intersection of these two lines. The same goes with angle 2 and angle 4. Okay, they're vertical angles. So then if I look at angle 1, I'm going to say that angle 1 is congruent to angle 3 because those two angles are vertical angles. The same goes with angles 2 and 4. So angle 2 is congruent to angle 4 because they are vertical angles, and the vertical angle theorem says that vertical angles are congruent. Okay, one more theorem here, and this is the congruent supplements theorem. So this one says that if two angles, okay, so if two angles are supplements, don't forget supplementary means you have two angles that add up to 180, and I made a mistake there, so supplements. Okay, so if two angles are supplements of the same angle, then they are congruent. And I'm going to show you what this is saying in the following example. Okay, so look at these two angles here, angle A and angle B. Angle A has a measure of 110, angle B has a measure of 70. If you add angle A plus angle B, the sum is 180. So angle A plus angle B is 180, which means they're supplementary angles. But also if you look at angle A and angle C, angle A is 110, angle C is also 70. So if you add angle A plus angle C, the sum is also 180 degrees. So that means, so therefore, I'll just write it here. Therefore, if I look at angle B, okay, angle B is going to be congruent, or is congruent to angle C. And that's obvious here by the example I just gave you for the three angles. Okay, so that's what this theorem is saying. So let's go to one more theorem. Okay, and this theorem it's called the congruent complements theorem. So this has to do with complementary angles. So this one says that if two angles are complements, okay, of the same angle, then they are congruent. So it's very similar to the previous theorem. The only difference is instead of supplements, it's complements. Okay, so let's look at this example here. Angle A, angle B, and angle C. Angle A has a measure of 30 degrees, angle B has a measure of 60. So if we add angle A and angle B, they add up to 90 degrees. So that means those two angles are complementary. And if we look at angle A and angle C, they also add up to 90 degrees, which means they are complementary. So then we can, by this theorem, we can say that angle B is congruent to angle C. Okay, so that's an example of those theorems. Okay, the next one is all right angles are congruent, but we know that all right angles have a measure of 90 degrees. That's what this box here means. So we can say here that angle 1 is congruent to angle 2 because of this statement. Okay, so let's go on to the next page. here in this page, I'm just going to go over this example. I'm going to skip this one, okay, and then I'm going to go over the last example. So this one is asking us to find all of the angle measures, and I'm going to use the theorems, at least one of them here, okay, or two actually. So this angle has a measure of 60 degrees, and I'm being asked to find all of the angle measures. So then I'm going to use the theorem that says that vertical angles are congruent, okay, from the previous page. So since vertical angles are congruent, this angle and this angle are vertical. So if this angle has a measure of 60 degrees, then this one also has a measure of 60 degrees. Now, something else that I need to notice, this means this is a right angle. But if this is a right angle and this angle here is also a vertical angle to that one, so then this angle is also a right angle, which means this angle has a measure of 90 degrees and this one has a measure of 90 degrees. So I just need to find this angle and that angle. So to find this angle here, since this angle is a right angle, that tells me that if I add this angle and this angle that is 60, they have to add up to 90 degrees. Okay, so then this angle is going to be 90 minus 60, and 90 minus 60 is 30 degrees. So that's the measure of this angle. Since this angle is vertical to this one here, okay, I'm just going to do that here. These two angles are vertical, then the two angles are equal, which means that this angle is also 30 degrees because of the vertical angle theorem. All right, let's go to the last example. So on this example, we're being asked to find the value of each variable and the measure of all angles. I only see one variable, but it might be the case that you might see 2 or 3 variables on a problem, okay? But this is how you do this one here. So first of all, from the first page again, I see that this angle is opposite to this angle, which means when these two lines intersect, these angles are opposite to each other, so that makes them vertical angles. So I'm going to use the vertical angle theorem here to help me find the value of x and then find the measure of each one of the angles. So then I can say that 4x minus 35 equals x plus 10. I'm going to solve for x first. So next I'm going to subtract this x from this side and also from this side. So then there is no x on the right hand side anymore. I just have a positive 10 or a 10. But this becomes 4x minus 1x will give me 3x. And I'm just going to bring this 35 down. So this is 3x minus 35. The next step is I want to isolate the 3x's. I have a minus 35. I'm going to add 35 to both sides of the equation. Okay? And this is the property of addition from last lesson. So then I have just the 3x's left on the left hand side, and then 10 plus 35, that combines to 45. Last step is to use the division property. I'm going to divide here by 3, and in the end that gives me the x by itself, and 45 divided by 3 is equal to 15. So here is the value of x. Now, once I know the value of x, I can easily find the measure of each one of the angles at this intersection. So let's start with this one here. So this one says 4, but instead of x, we just found that x is 15. So 4 times 15, okay, minus 35. 4 times 15 is 60, and 60 minus 35 is 25 degrees. Okay, so this angle here has a measure of 25 degrees. But if this angle has a measure of 25 degrees, I know this one is also 25. But I can also check, because if x is 15, 15 plus 10, that's 25 degrees. Don't you agree? Okay, so we have these two angles. Now, I'm going to use something that we learned the first couple of weeks. If I just look at this angle here, okay, this big old angle, and this angle, they have to adapt how many degrees? Can you remember that? They form a linear pair, and linear pair angles are supplementary, which means they have to add up to 180. So then if I want to find the measure of this angle, I just take 180 and subtract the measure of this angle, which is 25, and that gives me 155 degrees. So the measure of this angle is 155. But if this angle is 155 degrees, this angle is vertical to that angle. So that tells me that this angle is also 155 degrees. So there we have the measure of all four angles. We find the value of x and the measure of all four angles. All right. Thank you for watching. I'll talk to you soon. Bye-bye.